by 2. Okay. What about the numbers divisible by 7? It's going to be a little bit trickier. Okay? Maybe we need to bring in a little bit of number theory here, okay, in relation to divisibility. Okay? Well, let's think about it. So let's just list out our numbers. Okay? So we have, let's say here's our x's. Okay? Let's just list them down here. Okay? And what we're going to do is we're going to do, let's say, modulo 7 to see what is the remainder after we divide by 7. Okay? So our numbers are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on and so forth. Okay. So what we'll do is we'll divide 7 into each one of these numbers, but we'll keep track of the remainder. Well, 7 into 1 won't go with a remainder of 1. 7 into 2 won't go with a remainder of 2. 7 into 3 won't go with a remainder of 3. 7 into 4 won't go with a remainder of 4. 7 into 5 won't go with a remainder of 5. 7 into 6 won't go with a remainder of 6. 7 into 7 goes once with a remainder of 0. Okay? And let's continue. 7 into 8 goes once with a remainder of 1. 7 into 9 goes once with a remainder of 2, 3, 4, 5, 6. 7 into 14 goes twice with a remainder of 0. Okay? But the important thing to know here is this, is that what we have is we have two different sets of remainders. Okay? Well, not that we have two different sets of remainders, we can actually see that we have repeating members of the sets of remainders. So the remainders, okay, the remainders on division by 7, okay, have to be, so these remainders, yeah, okay, these ORs are elements of the set 0, 1, 2, 3, 4, 5, and 6, okay? So if you're some remainder, you have to fall into one of these particular, if you, after division by 7, okay, your remainder has to be one of these particular values, okay? Actually, each one of these values creates what's known as an equivalence class, okay? And I'm not going to talk too much about it, okay? So we have equivalence classes, okay? But the important thing to know here is that there's 1, 2, 3, 4, 5, 6, 7. So there's 7 equivalence classes, okay? Equivalence classes. So what you can actually see is that if we continue on this pattern here, okay, from, let's actually do them in this fashion here, okay, the x's and then modulo 7, okay, the remainders, well, when x is 1, 2, 3, 4, 5, all the way through to 700, okay, the remainder is going to be 1, 2, 3, 4, 5, actually let me put in 6, 7, now all the way through 6, 0, and then it starts off again, and that gives us the 0 here. The point being that these divisors, yeah, okay, that when we divide any one of these numbers from 1 to 700, okay, by 7, okay, when we divide them by 7, the remainder has to be either 1, 2, 3, 4, 5, 6, or 7. And there's 7 of these classes, yeah, okay. So you can see the pattern is going to continue. The pattern is going to continue all the way through. There's the cardinality of our set, okay. So the cardinality of this set X, okay, okay, and recall that X is the set of x's such that X is an integer and X is bigger than 1 or equal to 1 and less than or equal to 700. And we know the cardinality of that is 700. Okay, the 700 values in here. So when we divide by 7, how many of these possibilities? There's 7 different classes. So actually, I think what I'm really trying to do, what I'm really trying to get across here is that the size of, okay, the set of divisors, okay, the set of, I suppose, x's, okay, such that x is divisible by 7, where x is divisible by 7, okay, well then the cardinality of it is equal to, well, there's 7 of these classes, yeah, okay, the ones that have 0, okay, the values that fall into the class that has remainder 0 are the ones we're interested in, and well, there must be 100 of those particular values, okay. So actually what we have is that this set of divisors by 7, okay, its cardinality is equal to 100, okay. Actually, we had done that already earlier on here, yeah, but we didn't really spell it out in that particular fashion when we looked at the even and the odd numbers, okay? How many integers in this set, okay, were divisible by 2? Well, once again, there's 2 equivalence classes. When you divide a number by 2, you either get a remainder of 0 or a remainder of 1. So there's 2 equivalence classes. There's 700 numbers in this list consecutive. So half of them, there's 2 equivalence classes, 700 divided by the number of equivalence classes, yeah, okay, tells us how many values there is in each list, yeah. So there was 350. In this case here, okay, we have the remainders on division by 7, that there is 7 equivalence classes. So each number, and they're all consecutive, has to fall into, and when we divide by 7, has to fall into one of these 7 equivalence classes, okay? And you can see it's a consecutive pattern that's working through, okay? So what we'll end up with is that there's 100 numbers in the equivalence class. Okay, guys. Guys, once again, my name is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video trying to put it all together, okay? Maybe I'll call this my first example of putting it all together, yeah, okay? I hope that this was in some way intuitive, and more importantly, I hope that it was actually helpful for you, okay? So once again, thank you for watching.